Hello, everybody. Welcome to our webinar today. I'm glad that so many people have registered and joined. So welcome to our Technology Selection 2023 webinar. Today, it's on automated bioburden testing, as stated in the invitation. We just had some problems to solve so that all our panelists, in particular Miguel from Lonza, could join in. I think currently he's joining via phone, but we have his slides. So maybe Miguel, can you hear us, and can we hear you?
Perfectly, and I was able to join
Good.
in Zoom.
Perfect. Very nice. So who do we have today? We have Miguel, as already heard. Miguel is joining from Visp in Switzerland. Miguel is a chemist by training. He has a PhD in bioinorganic chemistry. Had his first experiences in pharma industry in quality control at Takeda in Ireland, and then changed to Lonza, where he started in the QC department. And then after a year at Paxvax, leading there the QA release activities, he rejoined Lonza and was then during 3 years in charge of the digitalization of QC activities at Lonza in Visp. And during the last 3 years, he has worked on automating and robotizing different QC lab activities. So welcome, Miguel. Very good to have you here. We have also Jörn Schmid from Goldfuß Engineering. Jörn is a freelance engineer, CEO of Schmid Projekte, his own company, which he started back in 1996. And he is a collaborator of Goldfuß Engineering, the company who has produced the system that we are talking about today. And Jörn is a sales and robotics expert for lab automation solutions in the field of automation, for example, cell culture applications, crop science applications, and many more. Yeah, and my name is Martin. I'm the founder of Lab Automation Network. I'm calling in today from Tübingen in Germany, and we are a small team of scientists here in Tübingen, orchestrating a network of technology leaders, which is the Lab Automation Network. Goldfuß is one of those partners, but many more. And today in this webinar, we have a nice agenda, which is first a quick introduction. We had some technical difficulties, so maybe a little bit late. I make it shorter at the beginning. And then as a second topic, we'll have the presentation of Jörn from Goldfuß for the fully automated bioburden testing system that we have built together at Lonza and Visp. And then we will have a part from Miguel telling us a little bit about the user's perspective on this project, which started a couple of years ago and is now installed and running. And he will tell us the motivation of Lonza, why they automated the bioburden testing process. And after that, I will show you some outlooks on how can this technology be used also for smaller labs in a more modularized way, to start with smaller modules, expand later, also use the existing equipment in the lab. And after that, we will have enough time for a discussion, a Q&A session. And please feel free to ask your questions. You can already start asking your questions in the Q&A window. You can also send messages in the chat. And we will not disclose any names or company names, personal names, because this webinar is also recorded. So you can watch it later. You will get the link to watch the recording again. And yeah, therefore we will not disclose any names. So feel free to ask your questions, and yeah, hopefully we will have a very nice discussion at the end. So for the introduction, I already mentioned what we are doing in the Lab Automation Network. As I said, we are an alliance of technology leaders because we believe that one single company will not be able, or hardly be able, to really cover all the different domains of expertise that are needed for proper, robust lab automation projects. And therefore, we have decided to select technologically leading companies who are willing to use their specific expertise and also to customize it, to adapt it to fulfill customer requirements, and also to work together in the network. So technology providers work with robotics companies like Goldfuß, and by this, being able to provide really complex and demanding lab automation solutions as the one that we are going to see today. We are a small team of scientists and project managers understanding the applications of the customers, making sure that our technology partners and solution providers can really build the best solutions and don't miss any requirement. Also the implicit requirements that are not specifically written down in any specification. So on the next slide, you see some of those partners in the upper left. Goldfuß Engineering. Jörn is working with Goldfuß. We have several more from different areas, some of them technology providers, some of them service providers for software, hardware, and other solutions. And just in a nutshell, a summary of what applications we currently cover in the pharma industry, in crop science, in cosmetics, in biotech companies, and chemistry applications. We use all the spectrum, the entire spectrum of lab automation technologies like robotics, liquid handling, powder dispensing, spraying technologies, application technologies, analytical technologies, and many more, and of course also the information technology needed. And in addition, we offer services, for example, before you start a project, to identify the proper requirements and to sometimes even prepare a strategy, an implementation strategy for automation in general and digitalization in your departments. And just a couple of pictures so that you have an imagination what type of solutions we are talking about. And this goes down to single cell injection in a microscopic liquid handling, automation, analytical technologies, and of course also standardized notations of workflows, ontologies, semantic systems, connectivity standards, and many more. Good. So this is where we are located. This is the beautiful town of Tübingen in the southwestern part of Germany. Fun fact, you see the castle here on the top of the hill. Here was the place where the first time DNA has been extracted back in 1869 by Friedrich Miescher. And we have a very famous university and also some interesting startups here, like CureVac, for example, trying to develop the mRNA vaccines that we have seen also from BioNTech and other players. Okay, but now coming to the topic of our webinar today, this picture I've taken early morning in an August day, a Friday in August 2016, when I had my first meeting at Lonza in Visp, and this is Visp with the Lonza campus down there. And my meeting was not earlier than 2 p.m. in the afternoon, so I had some time, and I started early, 5 o'clock, to take my car and drive to Zermatt to see for the first time in my life the Matterhorn. So this was also from this perspective a very successful business trip. And then I took the Gornergrat train to the summit, and then to the Gornergrat, and then I ran down again to Zermatt, took the train and then my car back to the meeting in Visp, where I arrived in time, and then we discussed the first ideas for lab automation, which then, amongst others, resulted in this system that we are talking about today. So now we, before I tell you everything, I'd like to ask Jörn to step in, Jörn Schmid from Goldfuß Engineering, and he will take over the presentation from here and explain you the content, the functionality, how the system is working, before we then also talk with Miguel for the customer's perspective. Please, Jörn.
Yes, welcome to the expert audience from my side. I will share my screen now. Is it visible?
Yes, we can see it. Please go ahead.
So Martin, I saw our robot automation has a nice place where it's installed now in Visp. Okay, I prepared 3 slides. In the first slide, I will show the manual processes and the demands we get from Lonza for the automation. And the second slide, we make a walk around the 3D model to explain a little bit the single function units, so that you can understand at the end the video we will see on the slide number 3. So right at the beginning, we had the challenge from Lonza to make a fully automated Bioburden water testing. I try to get my laser pointer. Okay. So there are 4 major process steps for the manual process. So at the beginning, we had for sure the labware and the samples. You know, here we have the sample bottles. We had the buffer and liquid bottles. Behind in the bag, the different agar plates, and for sure the filtration kit. The second process step, if you have all that stuff available to make the filtration process in a safety workbench. In this case, we had the filtration kit from Merck. We are not limited to that, but this was a given filtration technology and filtration kit for that. The third process is the incubation, 2 different temperatures over 5 days. And the fourth process step is the plate monitoring, checking the growth daily. And all that, the whole process had to carry it out under controlled conditions. So these were the demands from Lonza to that time. These 4 items may slightly be different from customer to customer. And at the end, the target was to design a fully automated system for all these processes. So this is a top view or a side view from the 3D design. This was our solution at the end. And I will go through the modules so that you can understand a little bit the function units. And after that, in the video, you see from the inner side camera situations, and then you might understand where we are in the automation line. Starting on the first module here is the control module, having an HMI, where we have the user management, the login, and the audit trail, and an additional workspace here that may be located in the lab room or in the office. where we have the visualization and the data tracking, the work plan for the day, what is happening in the line, where are my samples and where are my plates, and all this information. The second module is the input module, where the operator is loading samples. We have here the sterile labware under a laminar flow. We have here a laminar flow, so this is similar to a workbench. We have here a curtain and a laminar flow, and the operator is able to open sterile packaging. And we have non-sterile components, as for example, the sample bottles. And this track here is leading to a disinfection airlock, where we have a disinfection step, in this case with isopropanol, for bringing in the non-sterile components. Then on the right side here is the storage module. We can have a capacity for 8 hours here in that size of storage. This was calculated for the needs that we have regarding the filtration methods that can occur over the day. And so the robot has enough filtration kits, plates, and buffer liquids for about 8 hours working. Then this is the detection module, where we have a robot in to check the plates once a day. After 5 days, the plates go to the waste bin here, or in case of growth, they are brought out here and the label is printed automatically. The operator can take the plate, put the label on, and do the next investigations. At the end here of the line on the right side, this is the filtration module, the workbench for the robot, where the real filtration happens. We have an electrical front window here, which is very similar to a normal safety workbench. The window is closed during the during the operation of the robot due to safety reasons. And all the components that are entering the workbench are passing a second disinfection airlock. In the module, we have the filtration process itself and the membrane transfer on the agar plates. We have the pipetting and the waste handling and the buffer and plate storage, so that the robot can proceed the different methods, filtration methods. In the back, we have the incubators for 2 temperature levels here. The capacity is about 1,000 plates. So over the 5 days, depending on how many plates per day we have, we can store up to 1,000 with 2. And for sure, if needed, we can add more incubators. This here is the cold storage. It's a fridge from 4 to 6 degrees Celsius, where we store the sample bottles. All that components are from the company Memmert, and they are developed for this automation system. They have an own automated transfer logistics system inside. We have 2 levels. This is the 750 liter incubator size, and we have 2 levels and 2 airlocks. So a top level where we have here the 60 and in the first level, and another 60 in top level, and also here we have 250 around in the first level, 250 in the second, and the same with a twice incubator. So storage enough. Then here in the back, we have a robot which is responsible for all the logistics. He's on a rail here and is running between all the modules and is responsible for handling all the labware, the samples from the beginning, from the input here in the sample fridge, then to the workbench, to the incubators, and to the detection module. So I think now this was one walk around the system. Maybe one more or some more details. We have 3 access doors for the operator. One is here on the left side, one here on the back on this first module, and a third one here on the back at the end of the aisle. So you can have a parking position for the logistic robot on the left side. You can enter in the line from here for cleaning, maintenance, and service, or you place the robot at the end of the aisle on this side, and you can step into these doors here for having access to the modules from the inner side. From the front here, we have these big 2 doors for the storage module, these 2 windows here for the detection module, the electrical window for access to the workbench, and on the back, here's a big door from the back side, also to access the workbench. We put it into single modules due to the fact that it should be extendable and scalable. So as I said, if we need, for example, more storage capacity, we can enlarge that logistic part here in the back. We can, for example, put a second storage module. We can put additional incubators at the back, so we can scale it up if we need more space or more capacities. We are flexible in terms of the filtration kits, which now is a Merck system here, but we are not limited to that. And for sure, we are flexible in terms of the labware, the sample bottles, and the other components that are needed. So I think we are ready now for the video. I will not speak too much during the video because you have to follow the movie and read some texts, and I will give only a few sentences. So the video was taken at the Goldfuß site. Few impressions at the beginning. All the labware and all the components are labeled. So this is the input. Disinfection airlock for the water samples. All the labware is registered before entering the line. There's also a check for the inventory. Starting with bringing the first sample. Second airlock. Scan all samples, buffers, plates, and filtration kits, having a data set at the end for each filtration. Small storage area. Taking the funnel with a membrane. Fluid level measuring so that we can calculate the speed of pouring it in. There's a fill level sensor. pouring sample or pipetting sample, depending on the method and the volume of the sample. Waste handling, filtration itself, Merck milliflex system, put a membrane on the agar, park the lid, discard the funnel, take this lid on top of the membrane and the agar, press it down, and back in the tower. Growth detection with each plate once a day, taking a picture, looking for growth. If there is growth, sending the picture to the operator in the office. Filtration with plate with growth in the output area. This is the sample fridge. This is the incubator with the logistics system inside for the up to 1,000 plates. Storage area from the back. Okay. This was the first overview about the automation system.
Thank you very much, Jörn. Very impressive. We got already a couple of questions. We will answer most of them in the Q&A session at the end. Just, I think, one quick question, because it was very technical. It says, are the incubators standard incubators, or are they customized for automation? Are they also from Memmert? And is 1,000 agar plates referring to the size of 90 millimeter plates or to the millipore, milliflex sizes? Jörn.
It's a customized solution. We developed it with Memmert. Memmert itself developed a new version, which is now available for the next Bioburden robots. Regarding the limitation is in height. That means we can have the maximum bottle, for example, is a 1,000 ml bottle, which is about 25 centimeters. We can have about 30 centimeters in that towers or in that single storage. And the diameter is not that critical. We can have a diameter, I think, about 130 millimeters, which means 13 centimeters. So it's not limited. We can have 90 millimeter agar plates, and the height might be very similar to the Merck plates. The height is about less than 2 centimeters, and we can have 8 or probably 10 in height in one tower. So the capacity would be the same.
All right, perfect. Thank you. Let's continue the discussion in the Q&A session. And thanks again, Jörn, for explaining this huge system. It's really impressive. Let me switch back to our presentation and show you our second speaker again, because he cannot join with his computer. Miguel?
No, I am with the computer now.
Ah, so we see you. Perfect.
I was able to do it.
Good to have you. All right, so should I share your slides, or would you do this?
I can do it. I can do it. So
okay, perfect. Yeah, so the stage is yours.
Trying to. Can you see my screen?
Yes, we can.
So we started the Lonza back this project with the creation of the team I work for. I am part of the quality operational excellence. At the time, back in 2017, I was not part of it, but it was called quality innovation. And the origin of this group explains a lot about the project. So the first starts with why do we automate? And oh, it is not working. No. So we started back in 2017. We knew we are going to have a huge growth at Lonza FISP. We knew we will not be able to hire the required people to sustain the growth, and we had to manage these constraints. So why we don't? So there are different reasons we could explain why we automate. We start with the reasons why we don't automate. We are not automating for profit. We are not trying to build a technology demonstrator. We are not a technological company. We're a pharmaceutical CDMO. Employer attractiveness was not an issue at the time. Now, anytime we hire someone for the lab, of course, we show the robots, and it is also it has converted into a turning factor. When you see innovation being in place, you are automatically in a better place to hire talent. Why we started this automation process back in 2017? As I said, growth automation, lab shortages, those were the main two drivers. And of course, data integrity was at the time, and it is still a big issue in pharmaceutical companies. And at the time, it was pretty much everyone was getting 483s from the FDA due to non-compliance issues and things like that. And having something like that in place puts you automatically in a different level. We started analyzing different processes in the labs. We started analyzing different labs, different technologies. And at the end, we came to the decision to automate or to start automating with microbiology testing. The reasons why: it is really labor-intensive testing. You're talking about a lot of samples, a lot of handling processes. It is a well-established pharmacopoeial method, so it does not depend on customer A or customer B, which it was important for us as we are a CDMO, and we do not want to automate something where we have to ask permission 25 different companies. In this case, we were independent, and it makes sense. And the last thing we saw, there were a lot of companies and hospitals, not only pharmaceutical companies, investing in automating this microbiology testing. Different approaches, different technologies, but we saw there is a big momentum in automating microbiology testing. So back to what kind of the slide Jörn presented. That's the process. In FISP, samples are taken, they are analyzed, they are incubated. There is a microbial enumeration testing, and afterwards, if necessary, the colonies have to be identified. Just to give you an idea, last year we had roughly 52,000 bioburden tests in the site in FISP. The picture Martin showed you at the beginning is a picture at least 7 years old. Now the site is completely different, and the biologic area is huge. And in 2023, the number of samples will be roughly 60,000 and still increasing. So one of the points we decided to automate was, of course, bioburden. It's part of microbiology testing. We have a huge amount of people, manual process, and that's why we decided to start with it. And within the bioburden testing, we started with the quantitative enumeration of bacteria and fungi with the filtration method, with the idea of automating this filtration, which was manually done at the time, incubation, avoiding transport of the samples from A to B, automating the counting, and in the end, creating a fully automated and fully digitalized process. So once this enters operation, and it will happen in the coming months, we will perform all the activities related membrane filtration testing in a completely paperless manner. And that's basically it from my side. Thank you very much.
Yeah, thank you, Miguel. Thank you very much. Indeed, it was in 2016 when I took this picture. Yeah, this was the first meeting. Yeah, and then in the following months, many months, we have identified the bioburden process to be automated. Good. All right. So I expect we need some time for the discussion. We got a lot of questions already. So as long as I'm pulling up again my presentation for the last part, I take one question already to you, Miguel, because it's related to the operation of the system. And it says, how long do you need to train persons to use the system? What is the usual level of interaction with the system? Are there different user levels available?
Of course, you need always different user levels available. So we have the way that the microbiology team is has been updated related to the automation. We have created what we call a technology team, and that's a group of SMEs. They are now in total 9 people who take care of those, not only this bioburden testing, but also other automation or robots we have implemented in QC microbiology in FISP. So those people are super users, let's say so, and they can pretty much do everything. Of course, there are some limitations due to GMP regulations and so on. We still have someone in IT who has all the permissions needed in case of a crash, in case something goes really wrong. But in case of normal operation, we have the super users, and then we have the regular users who fill the system with samples, with plates, with consumables. So with those 2 levels, we cover everything. And there is a basic training. There is a what we call a learning module where you have to pass an examination, an online test. And there is a hands-on training. And this training, the plan is every time we have the shutdown due to recalibration and service, the training has to be repeated. That's the approach we have in QC microbiology FISP.
Thank you very much. Good. So for the last part, I would like to tell you something about how to make this kind of automation accessible also for smaller labs. What strategies and what requirements do we see here? Before we then go to the discussion, again, we have a lot of questions already. So what are the strategies and the needs behind? So first thing is what we often see, and we talk, of course, as some of you know, we're talking to many other customers as well who could use such a system, and they ask us for flexibility quite often. So the needs change not only in terms of throughput numbers, but also in terms of connection to other systems. We'll come to that later also in the discussion. It has to be reconfigurable from time to time, and also in some cases open access, which is more a general requirement that we see in lab automation. Many customers don't like vendor lock-in, so customers seek independence from individual vendors. Also in particular, and this is not only true for the bioburden system, when it comes to software solutions like orchestration layers or scheduling layers. And then one solution can be modularization, yeah, to separate the individual work steps that we have seen in the entire solution that Jörn showed. We separate some of those work steps or workflow parts out and build modular systems, which are more and more preferred over fully integrated systems. If throughput is not the main objective, and also if it's then possible to use smaller laboratories, and then be able to scale the system by adding more and more modules that can then also be automated. And then one important prerequisite for this modularization is interoperability. So it must be possible to use individual modules and use, for example, a readout module, a colony counter from a different company and different incubators. And also each customer has a different IT landscape to connect to different LIMS systems and so on. And therefore, we are very much dedicated to standardization, use standards in connectivity, in data formats, so that such modularized concepts can be easily implemented. So what does that mean? In this case, Jörn has shown you this large system, and what we are now doing is taking the central part of this, which is the filtration workbench, and combine functionality from other parts like the input and output module, or the input module for materials and samples, the fridge, the incubator, to one single module which fits into normal laboratories. And this is a standard workbench and that is used, a clean bench equipped with automation. We have in the middle the robot. We have on the right side the Oasis pumps for the filtration. We have a storage unit here in front with cooled storage places for samples. We have an input area here in the front where the operators can bring in their filtration kits and the membrane, the agar plates. Then we have on the left side here, the module which is separating the funnels and combining the membranes with the agar plates. The upper left, we see the incubator here in orange. So all the functionality that is needed to perform the filtration is included here in the system, and it has a smaller walkaway time, of course, a smaller sample capacity, almost the same throughput, but more user interaction, more operator interaction. Here you see the individual modules. I think you have understood what's all in there. We can provide you with the slides so you can refer to it. And then the trick is to combine this with equipment that you have already in the lab. This is the filtration module, and you might have your own incubators, your own colony counters, or even another type of automated incubation and readout system, like from the colleagues from RMB, with the Growth Direct system. It's another format for the filtration kits, and it's also no tweezerless membrane technology, but it can be combined. We can discuss this a little bit later in the Q&A session with this filtration system that we see on the right side. And you can do the logistics, the transport of the individual materials in between those modules manually in the beginning, but you can also use new technologies like mobile cobots, which are now robust enough to perform such tasks. Let me see, I hope we can show you this video. Yes, we can. So this is one of our partners in the network, United Robotics Group from Germany. And what they offer is a solution that's not only capable of transporting plates, but also to open lids, open doors from incubators, doing much more, even as you see here, opening and closing caps, loading centrifuges. This is an environment from a clinical chemistry lab. where the solutions are already used in a number of hospitals. It can go through doors, it can use elevators if needed even, and this allows to scale your throughput and your sample capacities using such systems. Make sure that the transport tasks are done even overnight without the user attendance, and then maybe later add another filtration module if you want to scale up throughput. And that's the way how we see in the future to integrate such solutions in the lab. And another option is if you need assistance in the more administrative tasks like documentation of the processes. We are using very much now augmented reality solutions, and this is from our partner company Augmenticon, who already offer very nice solutions for GMP manufacturing and QC environments. And the camera recognizes also the volume. If you set the right volume, it gives commands, which is the next task to do. It says this is the right sample. It recognizes the samples and documents everything, which is a very good relief from manual work. I stopped the video here because we want to discuss some more questions. So these are the technologies we use to apply the technologies that Jörn has showed you. Also in smaller labs, start with a single unit and then grow and increase the degree of automation over time. I hope this quick overview was sufficient. But we can do deep dive sessions if any of you would like to learn more and discuss in more detail. Please feel free to reach out to us. We would love to set up an individual meeting with the experts from the involved companies. Now let's go to the discussion, and I'll ask Miguel and Jörn to switch on their cameras again so that we can discuss the questions that we already had, which are a lot. So maybe we start with a software question. It says, which software is running this? Is it a custom software? And second, how are the modules and devices integrated? Are there interfaces? Are the interfaces proprietary or standardized? Maybe Jörn, you can comment on this. Which software is controlling the system?
So we have three softwares in the system. You have the HMI software, you have the robot software, and you have the PLC software, which is Siemens based. Siemens program modules, which allow to have at the end validation for GMP certification. And then this is the, let's say, the control level where we all connect all the devices and for the automation line itself. And for sure, we have the data summary, the data sets, and have a connection to the LIMS system from Lonza in this case. So the data is stored on an IPC, industrial PC in the line, which is called a bridge PC. Is a bridge between the robot automation and the LIMS system and the inventory manager, I think. Maybe, Miguel, you can describe the Lonza side a little bit, which are the software interfaces.
So we have three interfaces. One is with the ERP system, one is with the LIMS system, and the third one is with the environmental monitoring system with MODA. So we have actually three leading systems depending on the type of sample or depending if it is a sample or a consumable. Consumables are managed in the ERP system and samples are managed either in MODA or in LIMS.
Thank you. But this is not yet following industry-wide standards like CILA 2 or LEDs or OPC-UA. But this is these are the standards that we apply now for our new systems. Okay, then next question shows that there is really good experience there with the Milliflex Oasis system. The question is, have you had any challenges with air bubbles forming between the agar and the membrane filters in connections with the uses of the Oasis Bioburden system in this automated solution?
Not at all.
We did, but it was solved quite quickly. Within 4 to 6 weeks, we had a solution, and it is really reliable. We were really surprised to achieve that level of accuracy. And compared to the manual process, now the automated process is better. So the last time we ran, a month ago, something like that, we ran a kind of capacity testing, and there were 600 plates in a row, basically within a week, and 0 bubbles. Manually, it would have been different.
Yeah, and we have a second question, same topic. How does the automated system perform this with respect to avoiding the formation of bubbles? Yeah, what's the trick to do it automatically? Can you disclose this, or?
Jörn, feel free.
There were a few impacts. Well, at the beginning, we had samples. I think 3 years ago, these were maybe different samples. We stored it a long time here. We do tests once, every 3 weeks or 2 months. We take the next one out of the stock, and we saw at the end if the material is too old here in Balingen, not in the lab for sure, but here in Balingen, we saw it's different if you use very old labware, which is also already stored 2 years here in Balingen, and we saw that there are differences in the batches from in this case the Merck plates, and then Lonza, during the tests, detected from time to time that bubble problem, and we did tests here in Balingen, our technology center, and programmed different moves of how we put the agar and the membrane, or the membrane on the agar, and how we press the lid. There were some investigations with convex forms and the point where we press the lid, and how we put on, as I said, the membrane on the agar. So this was a development step by step, and now we had optimized it as Miguel said, and at the end we solved it. And as Lonza uses the plates very quickly, so it's a standard, and it's okay now. Yeah.
Yeah, thank you, Jörn. And this leads me to the next couple of questions. I take them for one. Some of the participants ask for the project time, the project duration. I mentioned that the picture of Visp was taken in 2016 already. That was not the point in time when we started, but as we discussed now with the air bubbles, there were a lot of problems to be solved. So how long did the project take from the kickoff until qualification?
The kickoff, I am at Lonza the only one still in the project. I was in a different role, but I was part of the project. The kickoff was in 2018. I don't remember exactly the months. I think it was September or something like that. The factory acceptance test was during the Corona crisis. It was March, April. We couldn't be there. So coronavirus was also not a hard stop, but it had some difficulties added to the project. The robot was delivered to Visp summer 2021. The IT, the IQ was done end of 2021. OQ was done September to December 2022. We had, of course, some problems, and now we are running the PQ. And we hope we will go live. Well, it doesn't depend completely on Lonza side because it has to be inspected by authorities. The Swiss authorities have already mentioned don't use the system before we see it in operation and before we give you the green light. So we hope we will finish in March the PQ, and the inspection is supposed to happen in the second quarter of April, May, June 2024.
Okay, and then a question about this. How did you qualify the system? Did you use the approach from European Chapter 516 and USP 1223 with accuracy and so on, or just a PQ?
So we follow the B model from the ISP. So IQ, so URS, FS, DS, and then IQ, OQ, PQ. Mm-hmm. But it is complex. It's not like an HPLC or a normal laboratory system you might have on your companies or at Lonza. We had to write completely new procedures for those devices, not only for this one, but all automation projects we have in place or we are implementing. It depends a bit on the system. So in this case, you have mechanical qualification, you have an electrical qualification, and you have a CSV qualification, and you have a methodological qualification. That would be in a nutshell. But the amount of validation documentation we have produced is astonishing.
Yeah. We're running out of time. I just wanted to catch up with the remaining questions. So one question that comes from the people who are using other solutions. Yeah. So how would the solution look like if you would not be, if it would not be a tweezerless filtration system? So with standard filter funnels and membranes, Jörn, would that be possible for the filtration as well?
Yes, we did first tests and concepts how to put the membrane manually in the agar, on the agar, and yes, it's not finished yet. For example, for the RMB plates, where we have this standard transfer, yeah, it's already in progress, and we have a solution for that. Yeah.
Okay, for those participants who have to leave now, thank you very much for joining. We will continue the discussion for a couple of minutes, and you can watch it then later on. Thanks for joining at this time. So then there is a question about flexibility. How much flexibility can be really added to the automation from a regular changing perspective? Or do I have to decide at the beginning of the design phase what type of media vendor, filtration system, and detection system I want to use? Jörn.
Yes, for sure. Before we can finish the design, we have to decide which filtration kits we have, or in which sample bottles, or which buffer bottles, and which plates, for sure. But this is part of the design, and if we have a GMP regulated project, the URS and the DS design specification and the risk analysis must be on a ready design. You cannot change it afterwards, because you have to step back to the beginning and change the requirement specification, the design specification, and that would not follow a GMP regulated procedure. So therefore, if the design design is freeze, you have to freeze the document, to sign the document, and then we stop in the next phase.
Okay, we have two questions about the uptime in percent and the robustness of the system. How often is there a failure? We know from other systems, which are much simpler, that this can be really a problem. Yeah, you mentioned the bubble forming already, but there are maybe other failure modes as well. As we have learned from Miguel, the PQ is outstanding, but can we say something about that already?
So at the beginning, of course, we had performance issues. It's normal. It's a new device. It's a prototype one. Now I think the longest we have tested it I think it was 5 days in a row, and we haven't had any issues. It was done end of November or mid-November. And now we are in the middle of the PQ. We don't have those tests yet, but we'll have or they have not been done yet, but we'll have a capacity planning test, hopefully at the very end, hopefully February or so. And the expectation it runs at least a week without any major issue. One of the biggest problems right now is to feed in the robot. So we cannot constantly feed in the robot because we don't have a lot of people training the system. So we can run it 20 hours, 24 hours, couple of days, but not much longer.
Okay. And then we have a question in the chat. How many machines for automated bioburden testing have you already built? I think, Jörn, this is also already answered. This is the first system you have built, but there is another in planning, or?
Miguel, may you inform?
So we have ordered already a second one. So it's going to be slightly different because, of course, there are some learnings we gained during this project, and the second one is going to be a bit more powerful, and regarding safety, much more powerful, because we will love to analyze with the second robot really hazardous samples.
Okay.
Yes, and we did 2 more concepts for 2 more customers now. We are on the concept phase for 2. As Miguel said, we have to adjust some technology and some materials. It's a little bit different, always the same, but different. And yeah, the interests are out there. Yeah.
Very good. Thank you. And then last question up to now, what is the regular requirement for the automated system? I think it should be a regulatory requirement for the automated system. Are there specific requirements for the automated reading of the plates and for the filtration unit? I'm not sure if the question is clear.
So I presume, so what we do with this, with the colony counting is not that complicated. It's growth, no growth. Is 0 or growth. So we keep it simple in that case, because we have to analyze the colonies anyhow.
Yeah.
There are some limitations, and it depends on the local authority as well. So we have to, anytime we start such a project, we have to send a letter to the Swiss authorities. We start conversations with them. We present their approach. They might give you an idea. They might not. And at the end, they have to come and inspect it, because at least for the Swiss authorities, it is like a new facility. It is not a new piece of equipment. It's like a new production train, and they will analyze it as it is, or test it as it is a new production train.
Okay. Now, one more question. How do you run the sanitization cycle with the robot?
So the robot has a biotrack on it. So the robot has a particle counter integrated in the system. During the PQ phase, we will have also, or we are already using them, mobile particle counters. And this will give us an idea about the amount of particles which are created. So not living particles, but dust and things like this, because you have equipment moving, and you will create some particles. Our idea is cleaning. The original idea is cleaning once a week, and then during this service period, a really in-depth clean. But we cannot guarantee that right now, because we don't have the final results from the biotrack and the mobile particle counters.
Okay, good. And just one more coming in. in case you have already validated all your methods, do you have to challenge the suitability of your methods again with this automated system?
They are compendial methods, so how can I challenge compendial methods?
Yeah.
Of course, we verify them against manual versus automated, but I cannot go to the authorities and tell them, hey, your method is not up to date. So that, let's say the playing field is described and we cannot move that. If the authorities in 3 years change their mind and add something, then we will have to adapt.
Yeah. Good. All right. No more questions. Thanks to our panelists. Thanks to all the participants for staying so long with us. So thanks to Jörn Schmid, thanks to Miguel Alvariño and for participating today and telling so honestly everything about the system. And thanks to all the participants for taking your time. And also a heartily thank you to the webinar team at LAN who prepared everything, Steffi Schulze, who did all the technical things, the invitations, Steffi Dreher for our subject matter expert for bioburden testing, and Nina Stahl for the project management. So, and by that, I close the meeting for today. Feel free to reach out to us if you have any more questions, and bye-bye.
Bye-bye.